Welcome guys. Today I'm gonna show you a milling option. It's called cylinder flats. I've been getting more and more these requests for milling. What's cool about cylinder flat is technically you're gonna see, but imagine that this is your bar, right? It's rounded. If you need to remove a flat, for example, like this, so that technically would look like that. What cylinder flats does, it's kind of similar, like you can use a left line, for example, or pocket, but pretty much what it does this. It's a pretty good time saver. Instead of going all the way back here, right? It actually calculates the cylinder radius, and it accommodates for that. And I'll show you like how to exactly how it works. And I don't have any part over here, but I'll show you the tool, and then we're gonna follow the pattern, okay, watching the position. So what I'm gonna do is I have a 3/8 end mill, but I'm gonna change it to 1/2 inch because it's just gonna be easier. Okay, so 0.5. Data. Let me see, where's the 0.37E, edit, assign, 0.5 end mil. Okay, so 250. And the reason why I have it 250, because remember the position, right? When we're gonna follow the position of the machine, the center, so this is a 0.5, 0.5. So the center, it's gonna be easy to see that it's going 250 over here or 250 over here. And what I mean by that is that technically, if you start, let's say you're 0, and you see the machine is going 250 plus this way, then you know that it's actually covering the center. Or for example, if the center of the part, let's say it's you're trying to remove 1/2 inch, and if the center would go to 1/2 inch over here, and then you see another 250, it would actually remove 0.75. So you don't always follow the center, you follow technically these edges, right? Okay, so let's do a small program. Okay, program edit, soft key, insert, okay, and then this is going to be an option, face machining, and right at the end you're gonna see this cylinder flat, right? So like it shows you the end mill, you have this little kind of drawing of the part. Okay, so now we have a cylinder flat, and it's gonna ask you, so if you're gonna do it on the face, you're gonna do X and Y. If you're gonna do on your outside diameter, right? So OD, so technically this is the part, so this is where you're gonna be working instead of over here. Okay, so Z and Y. Now position C, if you have a part that you're trying to, let's say, remove this, and you have a keyway or whatever, then you can rotate your C, but we don't have anything, so position C 0. Now radius of cylinder plane, so now it's asking you, where do you start the part? So let's call it, my part is 2 inches and 200. All right, so from center to over here it's gonna be 1.1. okay, so cylinder R, radius of cylindrical plane, 1.1. and the reason this is important, because like I said, it's gonna be cutting on the radius. Okay, now bottom face roughness, so the finish, if you're gonna press 9, it's gonna apply 3,300, so thinner finish for a nicer, well, technically for a nicer finish. I'm gonna press that enter button. And it's telling me illegal format. 100, okay, enter. So now choices of my end mill. So I'm going to my tool windows, data. I only have one that's populated. Okay, rougher and finish. Now approach, we're gonna do the auto set. Same thing on the finish, auto set. Now this is gonna be typed. So you have bidirectional 1, bidirectional 2, unidirectional, and unidirectional 2. So I'm gonna pick the bidirectional 1 on both. The depth of cut. So let's call it, we wanna take 40,000 per pass. Width of the cut, so if you have a half an inch end mill, let's go 250,000 on both. And then my speed, let's call it 300. Feed rate 5,000. Okay, and then M8s, I don't care about that, right? Now, you only have one option, right? Once you're gonna go to the figure. So it's square. And now this Shift R, it says plain Shift R, and you're not gonna see it. It's just I kind of drew a little bit basic square. It's asking you how far you wanna go. So let's say that I need to cut this down to 2 inches, right? Okay. So my Shift R would be 1 inch. Okay. And then starting point Z, so let's call it, so let's do this is my part, right? The part is 2.2. I'm gonna try to bring this to 2 inches. Let's call it over here, and I need to cut it, I want it to cut, let's say from here down to 1 inch. So starting point 0, starting point on the Y, let's call it minus 0.5 on a Y, and then how far we going on a Z, we want to go 1 inch and 0.5 on a Y. So 0 is going to come down on a Y a half an inch, okay, and if the half an inch is not going to work for you, let's say it's too high, then drop it to 3/4 or 1 inch. So if you have a part, come close to a part, drop the tool a little bit and see where's the center, or actually even, so for example, make sure your tool kind of starts over here. So instead of feeding into the material, for example, it feeds right under, so then when it goes up on the Y, right, and it shifts, it doesn't, like I said, it doesn't plunges into the material. It gives you a little bit time. And then, you know, if you got, if this is going to be successful, then you can raise it. Usually it actually feeds into the material, so it's not like it's going to wrap it, but safety first, I always say, right? Okay, so if I'm going to touch this cylinder flat, as you see, it actually made a really nice drawing for us. So it made a drawing, this is the radius that it's going to start. This is that 1.1, so this is 2.2 inches diameter, and this is that finishing flat that we have. Let me see if I'm gonna go to the program, toolpath, part. It just shows you as a regular line. Let's do scale change, 0.4, part, okay, path continue. Okay, so as you see, so everything looks good, right? Now what I'm gonna do, let me see, to actually go back, position, this option is called, okay, cylinder flat, right? So CYL dot flat. I don't have a lot of hopes for the manual because whoever wrote that manual, I think they should be writing novels. Manual, Mazak. Okay, so CYL dot flat. Okay, so find it, see if they give us any information. Okay, so we have something. So right now, it's showing us the type of face machining we have available. Face mill, top end mill, stab pockets, pocket mountain, pocket valleys, and slot. Okay, we press again for another one. So it says round by round bar material milling, cylinder flat. This unit is selected to cut cylindrical surfaces of a round bar material with an end mill. Tool name scheme for tool number scheme. The data position C, cylinder R, bottom, blah blah blah. Right? It's a cylinder R. Okay, depth A. So depth of cut. This is gonna be rougher. This is that finishing pass. End mill. You know, a bottom code selected out of the menu. Automatic tool development. Okay, now when two bidirectional is selected for the other code, type in the tool sequence. So as you see, there's approaches, right? So this is rapid feed, and this is how it's gonna feed. Down, 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 right? Instead of, let's say, going in, pulling out, it's gonna do your pass. So technically, it's just gonna follow this path. So it's similar to what they actually did with the groove. Then you have approaches. Then when second unidirectional is selected for the code type in the sequence. So as you see, this is same thing. This is gonna be your cutting feed, rapid, cutting feed, rapid, cutting feed, rapid, cutting feed, rapid. Okay. And technically, as you see over here, so number one, let's call it, the tool moves to rapid feed rate to approach point. That's going to be the 1. The tool moves at the rapid feed rate to the position enter in the parameter E9 to the clearance position. So number 2 and number 8, the tool's cutting, and number 8, it starts to cut. I don't know how else to kind of, you know, when you look at through these manuals, they're literally their shit. Like it doesn't give you like a lot of information or even nice examples. Okay, so you have a cylinder, and it's kind of showing you what it does. See, it comes in, and it follows this cylinder. So the smaller this gets, the smaller the what do you call it? Smaller the cutting kind of gets, because instead of, like I said, instead of coming out, right, it just gets smaller and smaller with the radius cylinder. This is a really great even tool saving, a time saving tool that's actually kind of available from the Mazak, and that's pretty much it. So there's really not much there, right? Let's cancel this. Okay, position. And let me see. Okay, so we got about 100,000. Let's see. So we'll do 50,000 cuts. So it's gonna do 2 passes. Okay, and I set my position Z. Like I said, we're cutting here. Oh, the problem. I didn't close the truck, so give me a second. Okay, and start. Okay. So this is plunging in. It's at what do you call it? So maybe let's kind of look at these numbers. Okay, let's see. So it's so right now. Okay, so our axis at 2 inches and 106. Right, and we're going to down to 2 inches. Okay. So it's going minus 750, right? And this is what we wanted, because remember, we want this to cut 1 inch. Okay. 1 inch here. But remember, this is a half-an inch end mill. So it's showing us that it's the center of this is at 750, and that 250 is what's gonna give us that, what do you call it? It's what's gonna give us the age. So it's actually showing us the center of the end mill instead of the edges of the end mill. It kind of makes sense. Okay, so now we're at minus 250. So that means now the center is going to be 250. Okay, so let me see. So it stops right here. Right, so it's showing us 250. Minus 250, because the 0 is right here, and from here to here is 250. So see what it does? The position shows us the center of the end mill. So in your mind, you can just calculate this edge or this edge, and you know it's actually hitting right that edge of that zero. Okay, 750. So now it's going. Same thing. It's following the Z. Okay, 250. So what I'm gonna do? Okay, so I see how it behaves. So what I'm gonna do is I'm just gonna, let's do what do you call it, illegal direction. See how it just runs the finish, and I'm gonna show you in behavior of the tool, and also on the position. Okay, approaches. Okay, 2 inches and 190,000. It peaks to 2 inches. Okay, goes sideways. Right, goes to the top, comes back to the zero, goes up, and goes higher. So it does this zigzag, and then it comes out. Okay. So technically what it does, it comes, let's say this is our part. So it comes in, and it does this, and then it pulls out. Okay, so let's rerun this again. This is actually pretty efficient, to be honest with you. Probably better than Pocket. Okay, so it's going down. It's gonna hit 2 inches. Okay, now it's moving on a Z. It picks up on a Y. It's going back. It picks up on a Y. It picks up on a Y and goes back to 50. And then retracts, goes to 0, and it goes home. So, like I said, so this is the direction it's following. Right, and technically, so it covers you once it removes enough material, and you're pretty much done. What do you call it? So, like I said, a great option, super easy to program. So once again, your starting radius. So if it's if you have 3 inches, then this will be 1.5 inches. Then however you need to come close to, but remember, from 0. So if you need to come to, let's say, we call this, right, 1.5, you need to remove 300,000, then that 300,000, this is where you're gonna put it here, Shift R. What's the ending diameter you need to be from the center, right? So 1.5, we're removing 300, that means that would be 1.3. So technically 1.3 will be here. The beginning, it doesn't matter if it's, let's say, cylinder. So, you know, we started from 0. Let's say you can start from 1 inch to 2 inches, right? So this is, you're gonna start P1Z, your starting point on a Z, and P3. Hey guys, so I kind of messed up because the video that I've recorded about the cylinder flats, the second portion, I've deleted it by an accident. I thought that that I got it transferred to the computer, but I obviously didn't. So also I noticed when I was recording, and even when I draw my little board, sometimes I have a tendency, because like I said, I have very little window to see what I'm actually recording, that it's a little bit too low. This whole point of this option, cylinder flats, and it's one of the easiest actually options to mill flats. You can actually, and I'll show you, you can do squares, you know, double flats, single flats, and whatnot. And the reason why it's called cylinder flats, because technically, if this is a cylinder, the way that actually the machine cuts it, it cuts it like this. It follows the actually radius of the part, as you've seen when I took the video of the manual. Under normally when you do flats, for example, and you program these, you go like this, right? and then you plunge in, and plunge in, or you can cut. It comes, you know, let's say even comes to the center, goes left, right, goes up, plunges left, right. It depends. I mean, technically, if you look at it from the side view, normally, for example, if I do flat, right, this is your part. That's how it looks. Your end mill comes in, let's say right underneath, and then it comes up, let's say, goes a little bit higher, right? Then comes down this way, or you can go this way, whichever you want to program it. So this is actually the cylinder flat, like the way it actually cuts. Like I said, it's much faster, I noticed, than line left, and it's also much faster than your pockets. And pockets is pretty simple to actually machine. When you think about it, because technically when you see it, it's like it made a drawing that you can remove a flat from the face, but you can also do squares and whatnot. So like if you had a, for example, part, you can do a flat here, and then create a second program. This is gonna be on a, let's say, C0, and the second you can do flat here, and that would be your C180, right? Or for example, if you want to do a square, same thing. You can do C0, 90, 180, and 270. So your C pretty much kind of dictates the location of the flats. So you can do hexes, you can do hexagons, squares, pretty much like whatever, you know, whatever you need to do. So you can split them in 5 pieces and like that. That's why it's actually like a pretty ideal. Now, just to explain, and like I said, I'm gonna clarify this a little bit more. So we're talking about Z and Y. Z and Y, obviously, it's much, when it comes to the clearances and stuff like that, usually if you can machine a hex and whatnot from the face, for example, it's much easier. But if you have a very long flat, you're obviously not gonna stick out your end mill, you know, 7 to 8 inches, or if you can even get one. So technically where you're done is like you have to come out, and instead of, you know, coming from the edge and mill it like this, you have to mill it, let's say, from here, right? So this is where the ZY is coming out. So you're doing this and you're dropping the tool up and down. So obviously your machine has to be capable of having on Y axis. So the position C, we just talked about it, right? So position C, normally if you don't have to orient your part to anything that you've previously done, or maybe to second side, you're gonna stay at the position 0. The cylinder radius, and same thing as like I've explained this, but the audio kind of sucked today, where if you have a part that's 5 inches, right? This is 5 inches. Your cylinder R is gonna be from the center to here, right? So the actually cylinder R in this on 5 inches will be 2.5. So whatever is the diameter of the part you're gonna mill, cut it in half. Unless you already have a flat over here or and whatnot. But like, let's say you got a, you know, perfectly round piece. So your cylinder R is gonna be half of the diameter that you're starting, to be actually more precise. And then you have your finish. So if you press finish 9, it's gonna apply 3,300 left over. If you're gonna go 8, 7, so technically the better finish you want, the less of the stock is gonna leave for your last pass. So then you finish up your tools. You know, technically when it comes to approaches and stuff like that, just set that to auto. Mazak does a really good job usually doing that. Your speeds, your feeds and whatnot, and then we're gonna come out to actually shape. So shift R, what it's asking you, so right, so we got cylinder, so let's call it 2.5 inches. Okay, and let's just to kind of clear this up. Okay, So 2.5 here, right? 2.5, we don't need that. So this is a cylinder R. Now it's asking us shift R, how deep we're gonna go. So let's say you wanna remove 200,000, right? So if you got a 5 inches total diameter, and let's say you need to go to 4.8, you're gonna remove 200 pretty much here. So once your part is milled, you're gonna look like this pretty much, right? So now you're not gonna have that top. So instead of 2.5, now you're gonna be 2.3 on this side. Now you're gonna have a P1Z. So look, you have a P1Z, so position 1 on a Z and position 1 on a Y. So if you wanna, let's say, start from a 0, and this is where I'm gonna try to kind of clarify, because look, when I was talking about if you have a part, okay, and this is your, we don't even need that. This is your part, this is your 0, okay, and we're gonna say that I want shift R, right? So let's say 2.3. This is how low we're gonna go, and then P1Z, let's say we're gonna start from 0. P1Y, so for example, let's start minus one inch. So the machine, so the tool's gonna come down to minus 1 inch. If then you have to consider the actually center is not gonna be 1 inch. If you have a 1/2 inch end mill, right, then it's gonna come to minus 0.75, because the bottom of the end mill is where it's gonna be at 1 inch, for example, which is, let's say, over here, right? Then P3Z, which is like position number 3. I don't know why it's like P3. So for example, we're going from 0 to, let's say, 3 inches, right? This is, we need to cut this section. So let's call this 3 inches. That's gonna be position P3Z, that's be 3 inches, and P3Y, for example, is gonna be plus 1 inch. So technically, what we're telling the machine, and I know like it shows the cylinder from the top, but obviously the Y kind of works off of like this side, right? So you're gonna have a, so the C will rotate technically here. The tool's gonna come down here, and then it's gonna go up and down, up and down, up and down. So we know we want to be here, and your Y is technically how long do you need to go before it covers your part. So depends on the diameter of your of the part. But if you are looking to the side, what it's gonna do, it's gonna start cutting small here, cut bigger, here, here, till it hits the depth. And then obviously if you would kind of look from the top, you're gonna see it goes 3 inches, right? Like now, what I'm talking about is, look, if you got a part, and let's say you want this to come down to a 0, and your tool, okay, this is your end mill. If you kind of like, if you have an end mill and you're gonna face it this way, okay, and then your part, imagine, is here, right? So your end mill is gonna come to a 0, and let's call it, this is a 1 inch end mill, so the center is gonna be 0.75 as a simple, like to make it simple, right? So on the position, you're gonna see that it's at minus 750, right? Because minus goes, if this is a 0, the position that machine's gonna show you, it's gonna be in a minus on left side, and it's gonna be plus on the right side. 750, okay, and then it's gonna, let's say, go down and continue on whatever path it's supposed to. You'll have to consider, see, this little section, because the center, it's gonna cut this, but sometimes at the edges. So if you're gonna look it from the top, okay, and you have the material removed over here, sometimes you're gonna see that these corners didn't get cleaned up because you have to send this end mill past the 0 to actually remove that material. So to clean it up, you actually have to send either the center or a little bit outside of the center of your part. I don't know kind of if it makes sense, but just imagine this, what do you call it? Imagine that you're trying to remove stock from here, okay? And this is a big end mill, right? So look, and this is obviously, this is gonna be that 0 position. So if it's gonna come down here, and this 0 and this 0 over here is gonna be flush. See, this section didn't get removed because the end mill didn't get to it. So you technically have to push your end mill past your 0. So if this is 1 inch, now we're gonna be at 0.500. You are gonna be right at the center. So I would even go 50 or 100,000, a little bit more, to clean this edge up and then have it go up, for example, and come back and do the same thing. So this is one of the things is that you have to consider, and I came across this with pockets and other things, is that if you don't go low enough, for example, or high enough, right? So you're gonna try to be as precise as you can, let's say on the Y. So, you know, this is, for example, this is your flat, and you see, you know, the tool's gonna come here. It's gonna go a little bit past here. It's gonna, let's say, come down here on the finish. And then you look at the part and you see on the finish, you still have that little unfinished radius at the end. So technically what you need to do, you need to pass, go a little bit higher on the Y, so that radius of the end mill actually cleans this up, and then more than half of the end mill should go above to also clean all these edges. So this is one thing about these cylinders. So you can start, like I said, you can start from a 0, but technically if you're using a half an inch end mill, start at minus 300, okay, instead of a 0. So that way, when you have a part here, okay, this is my 0, right? The end mill is gonna start here, as you see. So this edge is gonna cut everything around, and you're not gonna end up with the end mill like here and leave you with that empty space. So this is pretty much cylinder. So P1Z, like I said, add at least half. So that center, it's gonna be start a little bit, you know, before 0. Your Y start always on a minus on a Y, and then go to the next Y on a plus. And like I said, that's gonna depend on the size of your part and the cylinder. But usually, if you're gonna call out a cylinder 2.5 inches, like I said, which is gonna be 5 inches. Using that option, the machine will calculate, or like I said, instead of, you know, going this way, it's gonna start on the actually radius, and then once gonna come down lower and lower, it's gonna start getting wider and wider. So that's gonna be within the parameters of the machine. So this is how you machine cylinder flats. It's like a really actually good option, and like I said, it's for single flat, 2 flats, like I said, pretty much squares and whatnot. Sometimes I think that might be even better option, just for the fact is that sometimes, you know, when you do, let's say, squares, to do squares, technically using a line left, you need to know the edges, like, you know, so technically you need to know that radius, right? To get actually this. I think that was with the line left, also with the line out. When it comes to this, and when it comes to also the pockets, you don't have to. But for some reason, unless somebody knows why, like when I do pockets, and I'll have to figure that out. I gotta play with finishes and all. The tool comes in and and it does its job, whatever it is, right? It will give me a pocket, then it's gonna go up, it's gonna come down, it's gonna run a finish, it's gonna go up, and then it comes down and runs a second finish. So technically it seems like it's doing 2 finishes, leaves a little stock for the first finish, and then it runs a second time. So if you do a lot of milling, a lot of pockets and whatnot, it's wasting time. Sometimes I'd rather do actually line left. With the line left, there's a little bit more work, but that pocket cylinder seems to be, like I said, I mean, that would be the fastest way to do flats. I think I'm just gonna start implementing that actually option a little bit more myself. So play with it. Like I said, I mean, all the basics. Now you all have to do is, like I said, offset, if change, push your Z away, run it dry, see how it behaves. Then you can go, drop your axe like 200-300 tons and higher, look how it's gonna behave around the part. And then once you feel comfortable, drop your axe to 50,000 or even to a 0 and run it. And hopefully it's gonna run good for you. And you can implement that option more often, and like I said, hopefully it's gonna make your life a little bit easier when it comes to programming. All right guys, thank you, and see you next time.